This is the part 2 video which contains most frequently or repeatedly asking equations. We summarize these equations after analyzing the previous year question paper. This will definitely help you guys to perform well in the upcoming VSSC Technical Assistant exam of Electrical. All the best, guys. Come to first point, magnetomotive force, MMF. It is the cause producing the flux. MMF equal to Ni, where N is the number of turns and I is the current through coils. The unit is ampere turns, AT. Magnetic field intensity or magnetizing force H. It is the MMF per unit length. Per unit length, H equal to MMF divided by unit length, which is equal to MMF divided by L. Unit is AT by M or AT per meter. Reluctance. It is a property of a magnetic circuit by which setting up of flux is opposed. S is equal to MMF divided by flux. Unit equal to ampere turns per Weber. Permeance P. It is a reciprocal of reluctance. S equal to flux divided by MMF. Unit is Weber per AT. Ampere turns. Induction motor. The direction of rotation of a three-phase induction motor can be reversed by interchanging any two of the three motor supply lines. Let the phase sequence of the three-phase voltage applied to the stator winding is ABC. If this sequence is changed to ACB, it is observed that the direction of rotation of the field is reversed, such that the field rotates counterclockwise rather than clockwise. However, the number of poles and the speed at which the magnetic field rotates remain unchanged. Thus, it is necessary only to change the phase sequence in order to change the direction of the magnetic field. If voltage is increased n times, taking into consideration of constant efficiency of a transmission line, the size of conductor will be, that is area of cross section, decreases to 1 by n square times that of original. Seventh one, what is current transformer? The secondary side of a current transformer is always kept short circuited in order to avoid core saturation and high voltage induction, so that the current transformer can be used to measure high values of current. Precautions are essential for ensuring that the secondary of a current transformer is not open circuited when the primary circuit is carrying current. This is due to dangerously high voltage might develop across secondary. Current transformer works on the principle of shorted secondary. It means that the burden on the system ZB is equal to 0. Thus, the current transformer produces a current in its secondary which is proportional to the current in its primary. Most important precaution in use of a current transformer is that in no case should it be open circuited even accidentally. As the primary current is independent of the secondary current, all of it act as magnetizing current when the secondary is opened. This results in deep saturation of the core which cannot be returned to its normal state, and so the current transformer is no longer usable. Again, due to large flux in the core, the flux linkage of secondary winding will be large, which in turn will produce a large voltage across the secondary terminals of current transformer. This large voltage across the secondary terminals will be very dangerous and will lead to the insulation failure, and there is a good chance that the person who is opening the current transformer secondary while the primary is energized will get a fatal shock. What is corona loss? The equation for corona loss equal to PL equal to 241 into 10 raised to minus 5 into F plus 25 divided by delta into root of R by D into V0 minus Vc whole square kilowatt per kilometer, where F is the supply frequency in hertz, R is the radius of conductor, D is the distance between two adjacent conductors, V0 is the operating voltage in kilovolt, V is the critical disruptive voltage in kilovolt, and delta is the air density correction factor. From equation 1 we can analyze that all other terms are just like constants, therefore PL directly proportional to F plus 25. The forbidden energy gap of semiconductor. For silicon, band gap at 0 Kelvin is 1.21 electron volt. And The band gap at 300 Kelvin is 1.1 electron volt. For germanium at band gap at 0 Kelvin is 0.785 electron volt and at 300 Kelvin it is 0.72 electron volt. For gallium arsenide band gap of at 0 Kelvin it is 1.52 electron volt and at 300 Kelvin it is 1.47 electron volt. The maximum efficiency in a transformer occurs when copper loss and iron loss are equal. Per unit load corresponds to maximum efficiency equal to root of Wi divided by WCU. Therefore, percentage load corresponds to maximum efficiency equal to root of Wi by WCU into 100, where Wi is the iron loss and WCU is the copper loss. The equations for single phase full wave bridge rectifier and three phase full wave bridge rectifier. Average output voltage V0 equal to 2 Vm by pi for single phase full wave bridge rectifier and 3 Vm by pi for three phase full wave bridge rectifier. Average output current I0 equal to V0 by R for single phase and three phase full wave bridge rectifier. Average diode current IDA equal to I0 by 2 for single phase full wave bridge rectifier and I0 by 3 for three phase full wave bridge rectifier. RMS diode current IDR equal to I0 by root 2 for single phase full wave rectifier and I0 by root 3 for three phase full wave bridge rectifier. Average source current is 0 for both single phase and three phase full wave bridge rectifier. RMS source current ISR equal to I0 for single phase full wave bridge rectifier and I0 into root 2 by 3 for three phase full wave bridge rectifier. 12th one. The RMS value of the current flowing through each thyristor of converter I equal to I0 into root of 1 by 3, where I0 is the constant DC load current. In a potentiometer, E directly proportional to L directly proportional to R, where E is the EMF of test cell, L is the balancing length of slide wire, R is the slide wire resistance. Also E1 by E2 equal to L1 by L2 equal to R1 by R2. Output torque of the induction motor at full load TFL equal to P out into 60 divided by 2 pi into NR. And output torque of the induction motor at no load TNL equal to P in into 60 divided by 2 pi into NS, where NR is the rotor speed, NS is the synchronous speed, P out is the output power and P in is the input power. The relation between the rotor air gap power, rotor copper loss and gross mechanical power output is, that is P in is to PCU is to PG equal to 1 is to S is to 1 minus S, where S is the slip. Accelerating power PA equal to PM minus PE. Accelerating torque TA equal to PA divided by WS. Synchronous speed in radian per second, WS equal to 2 pi ns by 60, where PM is the mechanical input power, P is the electrical output power, P is the number of poles and F is the supply frequency. In PMMC meters, deflecting torque TD equal to BINA, where B is the magnetic flux density, I is the current, N is the number of turns, A is the area of cross section. 18th one. Average output voltage of fully controlled wave rectifier is V average equal to 2 Vm by pi cos alpha, and the other equation for V average equal to E plus IARA. We know that Vm equal to root 2 Vrms and E equal to Kn phi n, where Vm is the peak or maximum voltage, alpha is the firing angle, E is the back EMF, Ia is the armature current, Ra is the armature resistance, Kn phi is the back EMF constant, N is the speed in RPM, Vrms equal to RMS output voltage. Waveform and different values. For sinusoidal wave, maximum value equal to Am, average value equal to 2 Am by pi, RMS value equal to Am by root 2, form factor equal to RMS value divided by average value. Then substitute the values of RMS value and average value, we get form factor as 1.11. Peak factor equal to Am by root 2, which is equal to root 2. For square wave, maximum value, average value and RMS value are Am. Therefore, form factor and peak factor are 1. For triangular wave, maximum value is Am, average value equal to Am by 2, RMS value equal to Am by root 3 and form factor equal to 2 by root 3 and peak factor equal to maximum value divided by RMS value, which is equal to root 3. For half wave rectified wave, maximum value equal to AM, average value equal to AM by pi, RMS value equal to AM by 2, form factor equal to pi by 2 and peak factor equal to 2. 20th one, accelerating torque in an electric motor TA equal to Tm minus Te, and TA, the other equation for TA is J alpha. Tm is the mechanical or starting torque, Te is the electrical or load torque, J is the moment of inertia, alpha is the angular acceleration. 21. Open circuit test. It is done by keeping one of the windings open without load. Usually high voltage winding is open, and applying rated voltage to other winding, usually low voltage winding, because it is easier to apply rated voltage. The current drawn from this terminal is the no load current, as a low power factor corresponding to the core loss component. Since the no load current is very small, it does not contribute to the copper loss. Core loss is calculated by multiplying the applied voltage and no load current. The figure shows the open circuit test. As the secondary side is open, the entire coil will be purely inductive in nature. So the power will be lagging due to the inductive property of the circuit. So low power factor wattmeter is used in open circuit test of transformer. Open circuit test is used to find the core loss of the transformer. The no load current equivalent resistance referred to the metering side. Next one is a short circuit test. It is done by shorting one of the winding terminal, usually low voltage terminal, and applying a small voltage across the other winding terminals, high voltage terminal, because the current in high voltage terminal will be less and easy to handle, and using a wattmeter to measure the power dissipated in the low voltage terminal. The wattmeter will indicate the full load copper loss. The figure shows the short circuit test diagram. In short circuit test, the secondary winding of the transformer is short circuited. As the secondary side is short circuited, the entire coil will be purely resistive in nature. So the power factor will be high or unity. A short circuit test is done to find the full load copper loss and short circuit current. Thank you.